Hello friends, welcome to Ccna video series lecture number 4. The topic of this lecture is IP version 4 subnetting of class C network and its variable length subnet masks or VLSM. So regarding the topic, our first question should be, what is subnetting? Subnetting is the method used to divide a single default network into more than one smaller logical subnetworks or subnets. Before digging deep into subnetting, let's see why do we subnet and what are its advantages. Number one advantage is affordability. We can use a single network at one physical location only. But if you have multiple locations in different cities, you will either have to purchase multiple networks or you can subnet a single network to use it at different locations. Number 2, reduced network traffic. Subnets make networks more efficient. Through subnetting, network traffic can travel a shorter distance without passing through unnecessary routers to reach its destination. Number 3, simplified management. It's easier to identify and isolate network problems in a group of smaller connected networks than within one gigantic network. Number 4, optimized network performance. As a result of reduced network traffic, its performance is optimized. That's enough detail. Now let's see how to subnet. The IP address 200.100.50.10 belongs to a class C network and its default subnet mask is 255.255.255.0. If we convert this subnet mask into binary, we can see that there are 8 bits all set to 0 in the host segment. This is a default class C network. These 8 host bits mean that we can raise the power of 2 to 8, which is equal to 256. So we have 256 values ranging between 0 to 255 for host segment in a class C network. But 0 and 255 are not valid host IDs because if we turn all the host bits off, we get the network ID 200.100.50.0. So we cannot assign 0 to a host device. And if we turn all the host bits on, we get the broadcast address 200.100.50.255. So we cannot assign 255 to a host device as well. Let's see it practically by assigning these addresses in network adapter settings. As you can see that when we assign 0 as the host ID, we get an error message that all of the bits in the host address portion of the IP address are set to 0, and when we assign 255 as the host ID, we get the same error message that all of the bits in the host address portion of the IP address are set to 1. This means that we always have to subtract 2 from 256, which equals to 254. So in an unsubnetted class C network, there are 254 valid host IDs. That's enough detail. Now let's jump into subnetting. Class C network is 200.100.50.0 and its default subnet mask is 255.255.255.0 and its CIDR value is /24, which means that there are 24 bits in the network segment. For subnetting, you will have to borrow bits from host segment. Let's borrow 1 bit from host segment for the subnetworks. So the new CIDR value will be /25, as now we have 25 bits for the network segment. To understand subnetting, carefully note down the following steps. Step number 1. our new subnet mask will be 255.255.255.128 as the spot value of the borrowed bit is 128. Step number 2, the number of subnets will be 2 raised to power 1 because we have borrowed 1 bit and that will be equal to 2, so we will get 2 subnets. Step number 3, number of hosts per subnet will be equal to 2 raised to power 7 because there are 7 bits left in the host segment and that will be equal to 128. But remember, we had subtracted 2 from possible host values, one for the subnetwork ID and other for the broadcast address. So our valid hosts per subnet will be 128 minus 2 equals to 126. Step number 4 is to determine the block size of the subnetwork. That will be 256 minus 128 equals to 128. Based on the values we got, let's generate our table of subnetting. The first subnetwork ID will be 0. Then we will keep adding the block size of 128 in the previous subnet ID until we get 256. So if we add 128 in our previous subnet ID, which is 0, we will get 128 as our next subnet ID. Now add 128 in the previous subnet ID, which is 128, we get 256. But we will not include 256 as our subnet ID because the maximum value of 8 bits is 255. As a result, we have got 2 subnetworks, 200.100.50.0/25 and 200.100.50.128/25. Now let's find broadcast address of each subnetwork. The number right before the value of the next subnet 128 is 127, which is all host bits turned on because we have borrowed 1 bit and 7 bits are left for the host segment. If we turn all the 7 bits on and add their spot values, 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, we get 127. So by adding 127 in 0, we get 127 as the broadcast address for the 0 subnet. Similarly, the number right before the value of the next subnet 256 is 255, which is all host bits turned on. So by adding 127 in 128, we get 255 as the broadcast address for the 128 subnet. Valid host will be between the subnet ID and broadcast address. So the first valid host for 0 subnet will be 1 and the last valid host for 0 subnet will be 126. Similarly, first valid host for the 128 subnet will be 129 and the last valid host for 128 subnet will be 254. As a result, we got 2 subnetworks 0 and 128 with 126 valid hosts and 127 and 255 as the broadcast address for 0 and 128 subnets respectively. Let's assign these numbers in our network adapter settings. If we assign 200.100.50.1 and press tab, we get the default subnet mask 255.255.255.0. But after subnetting, the resulting subnet mask is 255.255.255.128. So instead of 0, change the value to 128 and press OK. It will accept the new subnet mask. Now instead of valid host, if we assign 0 as the host ID, which is our first subnet ID, an error message will appear saying that all of the bits in the host address portion of the IP address are set to 0. If we assign 127 in the host segment, which is the broadcast address of our first subnet, an error message will appear saying that all of the bits in the host address portion of the IP address are set to 1. So we can assign any value between 1 to 126, which are the valid host IDs we found in the 0 subnet. Similarly, if we assign 128 in the host segment, which is our next subnet ID, same error message will appear saying that all of the bits in the host address portion of the IP address are set to 0. And if we assign 255 in the host segment, which is the broadcast address of 128 subnet, same error message will appear saying that all of the bits in the host address portion of the IP address are set to 1. So remember that we cannot assign network ID and broadcast address to a host. We can write complete subnetwork values by the help of generated table. So for the subnet ID of 200.100.50.0, the complete table with all valid host IDs will be, and for the subnet ID of 200.100.50.128, the complete table with all valid host IDs will be. In the previous example, we borrowed 1 bit. Now let's borrow 2 bits from host segment for the subnetworks. So the new CIDR value will be /26, as now we have 26 bits for the network segment. Follow the same steps as in our previous example. Step number 1, our new subnet mask will be 255.255.255.192, as the spot values of the borrowed bits are 128 plus 64, that is equal to 192. Step number 2, the number of subnets will be 2 raised to power 2, because we have borrowed 2 bits, and that will be equal to 4. So we will get 4 subnets. Step number 3, number of hosts per subnet will be equal to 2 raised to power 6, because there are 6 bits left in the host segment, and that will be equal to 64. But remember, we had subtracted 2 from possible host values, one for the subnetwork ID and other for the broadcast address. So our valid host per subnet will be 64 minus 2 equals to 62. Step number 4 is to determine the block size of the subnetwork, that will be 256 minus 192, which equals to 64. Based on the values we got, let's generate our table of subnetting. The first subnetwork ID will be 0, then we will keep adding the block size of 64 in the previous subnet ID until we get 256. So if we add 64 in our previous subnet ID, which is 0, we will get 64 as our next subnet ID. Now add 64 in the previous subnet ID, which is 64, we will get 128 as our new subnet. Now add 64 in the previous subnet ID, which is 128, we get 192 as our new subnet. Now add 64 in the previous subnet ID, which is 192, we get 256, but we will not include 256 as our subnet ID, because the maximum value of 8 bits is 255. As a result, we have got 4 subnetworks: 200.100.50.0/26, 200.100.50.64/26, 200.100.50.128/26, and 200.100.50.192/26. Now let's find broadcast address of each subnetwork. The number right before the value of the next subnet 64 is 63, which is all host bits turned on, because we have borrowed 2 bits and 6 bits are left for the host segment. If we turn all the 6 bits on and add their spot values, 32 plus 16 plus 8 plus 4 plus 2 plus 1, we get 63. So by adding 63 in 0, we get 63 as the broadcast address for the 0 subnet. Similarly, the number right before the value of the next subnet 128 is 127, which is all host bits turned on. So by adding 63 in 64 we get 127 as the broadcast address for the 64 subnet. Similarly, the number right before the value of the next subnet 192 is, which is all host bits turned on. So by adding 63 in 128 we get 191 as the broadcast address for the 128 subnet. Similarly, the number right before the value of the next subnet 256 is 255, which is all host bits turned on. So by adding 63 in 192 we get 255 as the broadcast address for the 192 subnet. Valid host will be between the subnet ID and broadcast address. So the first valid host for 0 subnet will be 1 and the last valid host for 0 subnet will be 62. Similarly, first valid host for the 64 subnet will be 65 and the last valid host for 64 subnet will be 126. Similarly, first valid host for the 128 subnet will be 129 and the last valid host for 128 subnet will be 190. And similarly, first valid host for the 192 subnet will be 193 and the last valid host for 192 subnet will be 254. As a result, we got 4 subnetworks 0, 64, 128 and 192 with 62 valid hosts and 63, 127, 191 and 255 as the broadcast address for 0, 64, 128 and 192 subnets respectively. Let's assign these numbers in our network adapter settings. If we assign 200.100.50.1 and press the tab, we get the default subnet mask 255.255.255.0. But after subnetting, the resulting subnet mask is 255.255.255.192. So instead of 0, change the value to 192 and press OK. It will accept the new subnet mask. Now instead of valid host, if we assign 0 as the host ID, which is our first subnet ID, an error message will appear saying that all of the bits in the host address portion of the IP address are set to 0. If we assign 63 in the host segment, which is the broadcast address of 0 subnet, an error message will appear saying that all of the bits in the host address portion of the IP address are set to 1. So we can assign any value between 1 to 62, which are the valid host IDs we found in the 0 subnet. Similarly, if we assign 64 in the host segment, which is our next subnet ID, same error message will appear saying that all of the bits in the host address portion of the IP address are set to 0. And if we assign 127 in the host segment, which is our broadcast address of 64 subnet, same error message will appear saying that all of the bits in the host address portion of the IP address are set to 1. So remember that we cannot assign network ID and broadcast address to a host. That's why we subtract 2 from possible host values. We can write complete subnetwork values by the help of generated table. So for the ID of 200.100.50.0, the complete table will be, for the subnet ID of 200.100.50.64, the complete table will be, for the subnet ID of 200.100.50.128, the complete table will be, and for the subnet ID of 200.100.50.192, the complete table will be like this. Thanks for watching. If you like the video, please subscribe to my channel and press the bell icon to get regular updates about upcoming educational videos. Thanks again.